Hello students, welcome to the next lecture on the cross ratio of the Mobius transformation. In this lecture, I will explain you more than 10 examples. Myself, Dr. Harish, you can follow and subscribe my YouTube channel. What we have discussed in our last lectures, we have learned the concept of the cross ratio, and that lecture you can find with the playlist complex analysis. You can see the concept of the cross ratio, fixed point, matrix representation, Mobius transformation, and many more lecture available in this playlist. You can follow and subscribe my YouTube channel. Now, the first thing is how we can write the cross ratio. How to write the cross ratio? That's a very simple. Make sure in order to write the cross ratio, you always need the four numbers Z, Z1, Z2 and Z3. Fine. And how you can write the cross ratio? It's a very simple rule. I can tell you firstly you can subtract them Z minus Z1. Fine. Then subtract the second part and you can write in the denominator Z1 minus Z2. And then again for the next part is a Z2 minus Z3, and for the last case is Z3 minus Z. And this is the way you can write as the cross ratio of the complex number. And it is denoted by the pair Z, Z1, Z2, Z3. But make sure students, if you write the complex number, if you write the cross ratio corresponding to four numbers, or if you change the order like Z1 you can write firstly, then Z, and then Z2 and then Z3. So what I did is I have interchanged these positions. Fine. Then the answer of these two numbers are not same. That means the while we can compute the cross ratio, the ordering of the complex number must be very careful. For example, if you consider four complex numbers 0, 1, iota and 2, and if you write the cross ratio corresponding to the 0, iota, 1 and 2, what I did is I have interchanged the position of the 1 and iota, then they are not equal. Why? Because firstly if you write the cross ratio corresponding to 0, 1, iota and 2, how you can write that? It will be the difference of the first number is 0 minus 1, then for the second number is 1 minus iota, then is a iota minus 2, and the last number is 2 minus 0. Fine. So what will happen? It will be minus 1. So I can write as a 2 minus iota divided by 2 minus 2 iota. Now you can rationalize this. It's a 2 plus 2 iota, 2 plus 2 iota. The denominator becomes 2, 4. 4 plus 4 is 8. The numerator becomes 4 plus 2 iota plus of 2. So that will be 6 plus 2 iota divided by 8. That will be 3 by 4 plus iota divided by 4. Similarly, for this second part, how you can write the cross ratio? It will be 0 minus iota, iota minus 1, 1 minus of 2, and 2 minus 0. Fine. So if you simplify them, it will be the numerator is a minus of iota. So that will be is a minus 1, it's a minus iota, it will be the plus iota. Fine. Divided by minus of 2 plus 2 iota. I can rationalize this is a minus of 2 minus 2 iota, minus of 2 minus 2 iota. The denominator becomes 4 plus 4 is 8. The numerator becomes minus 2 iota minus minus plus of 2. Fine. So if you separate them, it's a 1 over 4 minus iota over 4, and clearly say both are not equal to each other. Therefore, the ordering must be very careful. Similarly, we can extend the concept of the cross ratio to the extended plane, that is a C union infinity. Fine. What you can do, you can write the cross ratio corresponding to these four numbers again, provided what is the difference is instead of writing as a infinity, you can firstly write as a z and then take the limit z approaches infinity. Fine. चलिए. And every cross ratio represents or preserves the every bilinear transformation preserve the cross ratio. That means if you have the bilinear transformation or called as a Mobius transformation, AZ plus B, CZ plus D, such that AD minus BC is my non-zero, or I call as W. Then corresponding to the four complex number W, W1, W2 and W3, corresponding to the complex number Z, Z1, Z2 and Z3. If you write the cross ratio corresponding to the complex numbers, corresponding to the complex number Z, Z1, Z2 and Z3, while you can write the cross ratio corresponding to the transformation W, W1, they are all equal. Fine. And how you can write the cross ratio corresponding to the first numbers? W1 minus W2, W2 minus W3, W3 minus W4 and W4 minus W1. Similarly for the Z complex. Now, after watching this complete lecture, you are able to solve all these 6 examples. You can note down these 6 examples, and once I will complete the lecture, you can solve these questions and let your answer in the comment box. Now let's start with the 10 plus numerical examples. I hope before I can start the first example, I hope you can like and comment on this video as well. Now what is given to you? Your target is to write the bilinear transformation. That means your target is to find the Mobius transformation, which map the point Z 1 iota minus iota to the W of iota 0 and minus iota. That means 1 is mapped to the iota, iota is mapped to the 0, minus 1 is mapped to the minus of iota. So I can write, whenever your target is to find the Mobius transformation, always use the concept of the cross ratio. Fine. So I can write the cross ratio like Z, because we need a 4 complex number. The 3 complex number is given to you. Fine. Fourth complex number is unknown, so I can write as a Z, iota minus iota. Similarly, corresponding to the W iota, because I write as a 1, corresponding number is iota firstly, then iota, corresponding number is 0 and minus iota. Fine. Or you can also write in this manner, like first number is Z. If I write the second number is my iota, no issue. Third number I can say it's a minus 1, and then I can write as a 1. The corresponding is, corresponding to the Z, it will be the W. Corresponding to the iota, it will be my 0. Corresponding to the minus 1, it is my minus iota, and then it is iota. Or you can write this number is, if you start from the 1, then you can write as a minus 1, then you can write as a Z, and then you can write as a iota. Then it, how you can write that? 1, the corresponding to the 1, it will be the iota. Corresponding to the minus 1, it will be my minus iota. Corresponding to the Z, it is my W, and corresponding to the iota, it is my 0. You can use either the case number 1 or 2 or 3. Choice is on your side. Fine. So let's start with this. I can start with the journal notation like W iota 0 minus iota, and it will be W is Z 1 iota minus 1. So can you write the cross ratio corresponding to the first case? It will be W minus iota, then iota minus 0, 0 minus minus plus iota, minus iota minus W. Similarly, can you write the corresponding number is Z minus 1, 1 minus iota, iota minus minus plus 1, and it's a minus 1 minus Z. Fine. If you compare them, the 1 is my Z1, iota is my Z2, minus 1 is my Z3, iota is my W1, 0 is my W2, minus iota is my W3. Fine. Now can you solve them? The numerator becomes iota. If I multiply them, minus iota minus minus plus 1. If you multiply them, okay, this number will be cancelled out. Fine. I can take as a negative common and it will be cancelled out. Minus iota plus minus omega plus W, iota plus W. It is a 1 plus, it's a Z minus 1, and again I can take as a 1 minus common. Fine. Then it is 1 plus iota over 1 minus iota. Fine. Can you find the value of the 1 plus iota over 1 minus iota? I can rationalize them. Fine. So the numerator becomes 1 plus iota square plus 2 iota divided by 1 minus iota square. It's a minus 1 plus 1 cancel. 2 iota divided by 2, that is iota. This value is my iota. Fine. Now you can cross multiply them because your target is to find the value of W. How you can find the value of W? I can cross multiply them. Iota minus W into 1 plus Z. It is iota minus iota Z into iota plus W. So can you open this bracket? Iota plus iota Z minus W minus WZ. Iota square is a minus 1 plus iota W minus minus plus Z minus iota W Z. Fine. So can you find the coefficient of W? So it's a minus of 1 minus of Z. Fine. It will be the minus of iota. It is minus minus plus iota Z. Constant you can write on the right hand side. Fine. It is a minus of iota minus iota Z. So can you find the value of the W? So I can take the real component is minus 1 plus Z. Minus of iota common is 1 plus Z divided by this is a real component minus and iota is common. It is 1 minus Z is the right answer of the problem. Or you can divide them. You can divide the 1 minus iota on the both side. It becomes Z minus 1 minus fine divided by minus of Z and 1 plus iota and 1 minus iota. And what is the value of the 1 plus iota, 1 minus iota? This number is my iota. So I can return this number is Z minus iota over minus Z minus iota is the right answer of the problem. You can check your answer in the examination as well, because when you substitute Z is equal to 1, if you substitute Z is 1, answer will be fine minus fine. It must be iota. So is it iota? You can rationalize it. It's a minus 1 plus. You can rationalize it whether it is a iota or not. So clearly say if you write in the numerator, so it will be minus 1 minus plus minus of 2 iota divided by 2. So clearly say it is my plus iota is the answer. Corresponding to the iota, it will be the 0. Corresponding to minus 1, it is my minus 1. So that is the right answer of the problem. Find the bilinear transformations. Again, you can see there are the 3 points given, but we need a 4 points. I can take it as a 1 is a W. The second pairs are my 0, minus 1, 1. And corresponding value is Z, W. Sorry, these values are my, which map this. So these values are my Z. These are not my W. These are my Z. I can map to the W as 1, 0, infinity. Fine. So by using the definition of cross ratio, we can substitute the value. That means, firstly, I can start with the say because left hand side is W. These are the values of the W. 1, 0, infinity. They are must be same to the Z. 0, minus 1 and 1. So can you write the ratio? It will be W minus 1, 1 minus 0. Now because it's an infinity, so what I can write is I can take it as a limit. Fine. Already W is given, so I can return as say W1. This number I can return as a W1 or I can return as a W3. Fine. So it is a W3 approaches infinity. 0 minus W3 and it is W3 minus W. There is no infinity, so we can write this number is Z minus 0 and so on. Fine. So I can take an limit W3 approaches infinity. Now, once you take W3 approaches infinity, what is the value of this case? The numerator becomes minus W3, denominator becomes W3 minus W. I can divide it by W3 on the both side. Fine. So this number will be 1 minus, fine. Now, as the W3 approaches infinity, this value will goes to the 0. So the answer will be minus 1. So this number will be minus 1. If you multiply them, it's a minus W plus 1 divided by plus 1. And the right hand side becomes Z. It's a minus of 2. it's a minus of 2z over 1 minus z. Fine. Now you can find the value of the w. So minus of w will be minus 2z minus 1. So you can take the LCM. It is minus of 2z minus 1 plus z. So minus of w will be minus 1 minus z over. Now you can take the value of the w. So w will be 1 plus z over 1 minus z. Fine. And you can check your answers. When you substitute, the value of the z is 0. The value of the w will be 1. So you can check when z is equal to 0, the value of the w will be 0. It's a minus 1 over minus 1 is a plus 1. When you substitute z is equal to minus 1, the answer will be, you can see when it's a minus 1, it's a 0. And you can see the answer is 0. When z is equal to 1, the numerator part becomes an infinity 0. So the all w is infinite. Now look at the second part. Your target is to find the fixed point. So we all know what is the definition of the fixed point. We have learned whenever you have the transformation w is equal to t of z, the fixed point says you can substitute t of z is equal to z. Fine. So I can say t of z is nothing but my w. You can substitute the value. What is the w is? Minus 1 minus z over z minus 1. So can you find the value of the z? So it's a z square minus z is a minus 1 minus z. That will be z square is equal to minus 1. Hence, there are the two fixed point which comes to be plus iota and minus iota. So there are the two finite fixed points. For more detail about the fixed point, you can watch the lecture related to the fixed points. 10 plus examples already available in the playlist. Okay, look at next one. Find the bilinear transformations and also find, this is the second part. So again, you have the 3 point given. Fine. So firstly, we can define the cross ratio. The cross ratio corresponding to the W, these are the values, iota, 0, minus iota, which is equal to Z, corresponding value is 1, minus iota, minus 1. How you can define the cross ratio corresponding to the first Z component? W minus iota is iota minus 0, minus minus plus iota, and minus iota minus W. Similarly, for the right hand side, it will be Z minus 1, then 1 minus minus plus iota, minus iota plus 1, and minus 1 minus z. Now your target is to find the value of w from these expressions. Again, you can see these are the free from the z. Can you solve this? I can write as a 1 minus iota over 1 plus iota. So can you simplify that? It's a 1 minus, the numerator becomes 2. The numerator, if you open the numerator, it's a 1 and 1 will be cancelled out. It's a minus of 2 iota. Its number is minus iota. 0 plus iota will be cancelled. The number becomes omega minus iota minus omega. So this number is my minus iota. Minus iota, I can adjust the number. Fine. I can take a negative as a common. Is it okay? Now you can cross multiply this. The rest expressions are simple. You can cross multiply them and you can expand. Can you find the value of the w? So w is my minus 1 minus of z. Fine. This number I can put on the left hand side is a plus of iota. I can put z on the w on the left hand side. And the rest of the expression I can move on the right hand side. So minus iota z. So what is the w? So I can take it as a 1 minus z. This is the real component. Minus of iota common 1 plus z divided by, it's a minus of 1 plus z. Fine. I can take an iota is a common or 1 minus z. Fine. Or otherwise you can see or I can take it as a 1 minus iota. Fine. I can take it as a z is common. Minus of z common is a 1 plus iota divided by, again from this case, it's a minus 1 minus iota, taken the pair of minus 1 iota. I can take an z, minus of z is common. then it is a 1 plus iota. Choice on your side. Fine. Now you can divide it, the numerator and denominator, by 1 plus iota. So this number will be minus 1 plus, and it's a minus of z. So what is that? It's a 1 minus iota over 1 plus iota, and this value will be minus iota. So this number is minus iota, minus minus plus iota is the right answer of the formulation. Second part is your target is to find the image of the exterior of circle under this transformation. The transformation is given to you as z plus iota, z minus iota. What is the meaning of that? This is the equation of the circle. Fine. Exterior of the circle. This is my exterior of the circle. Fine. This is my z plane. And your target is to find the image in the w plane. This is my u, this is v, this is x, y. So what is the image of the w plane whenever you have map exterior of the sun? So first of all, your target is to find the value of the z. Fine. How you can find the value of z? There are the two ways. Firstly, you can cross multiply them and find the value of z, or we can use the concept of the inverse of the Mobius transformations. Fine. Because we all know if you have the transformation az plus b divided by cz plus d, then we can find the value of the t inverse, which is defined as minus of d, fine, and minus of a. Basically, they are reversing the coefficients of a and d with a negative sign. And if w is equal to t of z, this number is my w is equal to t of z, and then this number is my z is equal to t inverse. So can you find the value of the z? So its the coefficient is 1 and it's a minus iota. So I can replace the coefficients. Fine. It's a minus of d, it's a minus of iota is a positive, and it's a 1 coefficient is my minus 1. So that is the value of the z. Whenever you have the Mobius transformation, you can find the inverse directly. Now I can substitute this value in the given equation of the circle. I can take on the numerator, iota is my common. So iota modulus w plus 1 over w minus 1. What is the value of the iota modulus? It is always 1. So I can write this number is w plus 1 greater than equal to w minus 1. Clear? I can substitute the value of the w. It's a u plus iota v. The value is u plus iota v plus 1 is greater than equal to u plus iota v minus 1. And then I can put the square on the both side. Then what is the value of the modulus z square? Whenever z is your a x plus iota y, this number is x square plus y square, where x is my real component. What is the real component in this case? U plus 1 whole square, and it's a v square, which is greater than equal to u minus 1 whole square plus v square. So can you solve them? So clearly say v and v will be cancelled out. So that's a u square plus 1 plus of 2u, which is greater than equal to u square plus 1 minus of 2u, which implies 4 of u is my greater than 0. That implies u is my greater than equal to 0. Fine. So what is the meaning of the u is greater than 0? Because u is the real component of the w. Remember, w is my u plus iota v. And what is the v? U is my real part. V is my imaginary part. So that means the real component of w is my greater than 0. So if you draw the graph, this is my u, this is my v. So what is the real component whenever u is my greater than 0? That means lies in the first and the fourth quadrant. So that is the image of the transformations whenever you have the circle, outside circle that maps onto the right hand side of the u-axis. Find the bilinear, next question is find the bilinear transformation which maps the point w and the z. Fine. What are the values of the z? 1, 0, minus 1. Corresponding value of the z is iota, 0, minus iota. Because the cross ratio preserve the bilinear transformation, preserve the cross ratio. I can utilize the concept of the cross ratio to formulate the bilinear transformation. Now, can you solve this? It's very simple. You can write the transformation like how you can start with this. So it will be W minus iota, iota minus 0, 0 plus iota, minus iota minus W. Similarly, on the right hand side, I can write as a Z minus 1, 1 minus 0, 0 plus 1, minus 1 minus Z. Now you can simplify these expressions. Clearly say 0 plus 1 and 1 minus iota cancel. I can take a negative common and I can adjust on the numerator, plus iota, iota plus W. It's a 1 and 1 will be cancelled out. Again, I can adjust the negative. The numerator becomes 1 minus and it's a 1 plus Z. Now, can you find the value of the W? Fine. You may use as a componendo and dividend rule. If you remember your 10 plus 2 or in your lower classes, what is the componendo or dividend rule? Whenever you have A over B is equal to P over Q, fine. You can apply the componendo and dividend rule is A plus B over A minus B, which is equal to P plus Q over P minus Q. Fine. This is the A, this is the B, this is P and Q. You can use as this. Otherwise, you can simply cross multiply them. What will happen if you cross multiply? So if you cross multiply, say iota plus iota z minus W minus WZ, which is equal to W minus WZ plus iota minus iota Z. Now you can put W on the left hand side, minus 1 minus Z minus 1 and plus Z, while all those terms which are free from the W put on the right hand side, minus of iota minus iota Z. So clearly say iota and Z will be cancelled, minus of 2W, iota and iota will be cancelled, minus 2. So minus of 2 will be cancelled, W will be iota of Z is the required transformation. And again you can check your answer. When you substitute Z is equal to 1, answer must be the iota. When you substitute 0, answer will be 0. When you substitute minus 1, answer must be minus iota. Find the bilinear transformation which maps the point. Again, that's a similar one. Fine. So how you can write that? It's a W. The corresponding points are 1, infinity, 0. It must be same as the corresponding point is my 1, 0, 1 and infinity. Now because this is infinity, so I can write this number is my W2. Sorry, this is my Z. Fine. And this number is my Z3. So I can taken the limit W2 approaches infinity, while on the right hand side I can taken Z3 approaches infinity. Rest are similar. Fine. Now this number is limit W2 approaches infinity and it's a Z3. So can you solve this expression? Because this is the infinity part. That will be W2 divided by 1 minus W2. What is the limit? As W2 approaches infinity, either you can divide the numerator and denominator by W2, or you can see this is the infinity by infinity form. I can apply the L'Hopital rule. So that will be minus 1. Similarly, for this component, whenever you will take the limit Z3 approaches infinity, the answer will be, again it's infinity by infinity form, it's a minus 1 over 1. So that number will be my minus 1. Fine. And this number is again minus 1, Z minus 0 over minus 1. Fine. Now you can see minus and minus cancel, minus and minus cancel, W minus 1 over W is equal to Z. So can you find the value of the W? W minus 1 is equal to WZ. So W is common, 1 minus Z is equal to 1. W will be 1 over 1 minus Z is the required transformation of this bilinear form. Construct the linear fractional that also called as the bilinear transformations as well as the Mobius transformations. I hope student you can like and comment on this video as well. Kindly follow my YouTube channel too. Find the bilinear transformation that points -1, 1 infinity onto the points 1 iota -1. These are the points of the W. These are the points of the Z. Fine, which are lies on the unit circle. Now, again, a very simple. We can again start from this case because this point is my infinity. So how you can write that? It's a W. These are the points of the W. 1 iota -1, and these are the points of the Z. Find minus iota 1, because this is my infinity, so I can write this number is Z3 taken limit as Z3 approaches infinity. Fine. If I taken as Z3 is infinity, that itself means that limit Z3 infinity. Fine. So can you find the limit? Z3 approaches infinity. What is the value of this case when Z3 approaches infinity? So that is my -1, because it's an infinity by infinity form. Fine. This number will be iota plus 1, 1 minus iota. So can you rationalize them? Fine. So that number will be iota. So this number becomes iota. Fine. So I can write this part is iota into W minus 1 over -1 minus W. This number will be my -1. Fine. And the denominator becomes minus common iota plus 1. Fine. Now you can simplify this. Can you find the values of the? Now you can cross multiply them. Fine. So that will be iota minus iota in W into 1 plus iota. It will be 1 plus W, or you can apply the component and dividend rule. Choice on your side. So that is a iota square is -1 minus iota W minus iota square plus W. So it's a Z plus iota W plus W iota. Now you can find the value of the W. That is the required answer of the given formulation. Okay, find the bilinear transformation that maps the given 3 points to the given 3 points of the W. That's again a very simple. Fine. You can write the cross ratio corresponding to, it's a W 0 iota 3 iota. It will be Z -1 0 1. So can you write the cross ratio? Now clearly say it will be my minus of 2 iota. Minus of 2 iota divided by minus iota, that will be my 2 divided by 3 iota minus W. It is my -1, it's a -1 cancel out. Z plus 1 over 1 minus Z. Now you can solve this number. 2W minus 2W iota Z. It is 3 iota Z plus 3 iota minus ZW minus W. Now you can find the value of dW, and that is the required answer of this formulations. Fine. Again, as I tell you again and again, you can check your answer in your examinations. When you substitute Z is equal to -1, your answer must be 0. When you substitute Z is equal to 0, answer must be iota, and so. Okay, find the bilinear transformation that maps the point onto the unit circle. That means whatever the points that map onto the -1, 0, and 1. These are the points of the W. These are the points of the Z. Fine. And finally, you have to find the under this transformation. So first target is to find the cross ratio. Fine. You can write the cross ratio very simply. Fine. Now, I think that's very simple. This is my -1 cancel. W plus 1, 1 minus W. It is Z minus 1 minus Z. So it will be 1 plus iota over 1 minus iota. So can you rationalize them? Fine. So if you solve them, that will give you iota. Clear? Now you can cross multiply these numbers. You can cross multiply, you will get the answer. W plus 1, 1 plus Z is iota minus iota Z into 1 minus W. Now you can open the bracket, fine, and finally you can find the value of W. So that's a very simple trivial examples, fine. Or you can see I can simplify this, or you can divide them. Otherwise, that is the required answer of the problem. Or better is you can divide by 1 plus iota or 1 minus iota, choice on your side. Second part is, once we know this is the bilinear transformation, your target is to draw the circle, inside circle. Fine. That means this is my circle, which is my inside circle in the Z plane, and your target is to find the image in the W plane. What could be the image of the W plane? So again, because the value of the Z is given to you, so can you find the value of the Z? I can use again the inverse transformations. I can replace the coefficients of the A and D with a negative sign. It's a 1, so I can write as a -1. Fine. Plus iota. It's a minus of iota. Minus of this coefficient is a minus minus plus, by using the same concept of the inverse Mobius transformation. I can substitute the value of the Z in the given expressions. So it will be modulus is strictly less than 1. Now you can simplify these expressions. It will be minus W plus iota is less than of minus W plus 1. I can put it as a square on the both side. I can substitute W is equal to U plus iota V in the given expressions. Fine. Now you can put as a square on the both side. Now you can use as the real component plus imaginary part, which is less than of real component plus imaginary part. Now clearly say it's a U square and U square cancel. Fine. Is it somewhere mistake? It's a, because otherwise this number is also be cancelled. Fine. So just wait. We can open it. I can go back here. So it will be minus of U minus of iota V plus iota, which is less than of minus of iota. Fine. It's a minus of iota square. It's a plus of V. Fine. It's a plus of V. Is it fine? So now you can write as a real component. Real is my only minus of U plus imaginary component is 1 minus V. Real component is 1 plus V and imaginary component is minus of U. Fine. Now you can solve them. It's basically 1 plus. Now you can solve the expressions. Fine. So U square and U square cancel. You can open the bracket. It's a square plus B square minus of 2AB less than of A square plus B square plus 2AB. 1 plus V square, 1 plus V square cancel. Minus of 4V is less than 0. That means V is my greater than 0. While V is the imaginary part of the Z. That means if you draw the graph, what is the imaginary part? This is the portion which map the inside circle to the upper half of the W plane. That means this is the upper half because this component is V. V is my positive. So inside circle of the interior of the circle of radius 1 is mapped onto the upper half of the W plane under the transformation equation number 1. Now, based on these examples, can you solve all these 6 examples in a very, very simple manner? So you can solve, you can see in these, some are infinities, some all are infinities, some are finite and so on. You can solve these questions. You can put your answer in the comment box so that I can verify and others can verify whether you understand these lectures or not. We will see the next lecture on the properties of the Mobius transformation very soon. Till then, you can share this video with your friends. Happy learning always. And don't forget to like and comment on the video. Thanks for the watching. Best wishes always.